My name is Arsh Ahmad, and in this video I'll be explaining a simple Astable multivibrator. I'll not be going into very deep. This is a simple explanation. Astable multivibrator is actually oscillator that generates square waves. So if you see, it consists of basically four passives and one active component, that is your optional amplifier. And now it has a positive feedback and a negative feedback too. This positive feedback is actually fixed resistors, and these two values actually mainly determine the time period of oscillation. So this is all. What about an SOL vibrator? I will not go too deep how it discharges and charges in this video, because I want to show you something interesting in this video. So firstly, let me show you the calculation. This is the time period of oscillation of an stable multivibrator. I have using a R of 10 kilo ohm and C of 47 microfarad. So this is actually 1 millisecond written here, but that's 1 second, so the time period is approximately equal to 1 second. Now let's come to the circuit. This is a LM358 operational amplifier. I'm powering it up using this dual minus plus 9 volt supply using this battery bank. And the R1 and I have choose the values of I have choose the R1 to be 100k and R2 to be 82 kilo ohms, because I want 50% of duty cycle. That's why I've chosen these values. And for R, I am using a preset that is max to 10 kilo ohms, and I'm using C of three values, that is 10 nanofarad, 47 microfarad and 220 microfarad, just to show you a little bit difference. And I've connected two multimeters to the same output. One is digital and one is analog. Why? I'll show you in a minute. So the first thing is that this is at 3.6 volt and this is approximately at 3 volt. There is some sort of error in the multimeter little bit, so that's why it is off. So this is not the thing that I wanted to show you, because since I'm talking about oscillation, it should oscillate. And as you know, in AC signals, when the frequency is high, the meter actually round off the points and it shows you the average voltage, and that depends upon the how a meter is accurate. So most of the meters are actually tuned for frequencies nearly equal to 60 hertz. So this frequency is actually too high as compared to 60 hertz frequency, because I'm using a really too low value capacitor. So what happens if I just switch it to 47 microfarad, because the calculations I have done here is for 47 microfarad capacitor that gave me 1 second of time period. So now this is the range selector, which I can select the capacitor and connect it to the main circuit. So currently it is at 10 picofarad nanofarad. Now let's move it to 47 microfarad. Now as you can see, the meter it is actually oscillating. It is hitting that rightmost part of the multimeter, and it is doing so because this is the I have set it up to the, as you can see, it is the 10 volt range of the AC signal. And since it is at the 10 volt range of the AC signal, it is actually maxing out the top value. If I just put into the 50 volt range, you can see it is properly oscillating between 0 to 18 volt. So what happens if I just increase the value of capacitance more? Let's put it to 220 microfarad. It is actually oscillating but really slow. So this was the experiment. You can use actually analog multimeter to visualize oscillations, and it is very cool thing to do. So you're asking, what happens if I just measure DC voltage out of it? Let's connect it with DC voltage, DC 10 volt. As you can see, it is holding a position at the near zero, because DC does not contains negative in meters. That's why it is showing zero wherever it is negative, or the positive it is actually going towards 9 volt, because our voltage actually moves from -9 to +9. So it's actually showing only +9 signal, and this -9 is not being able to display here. So this was all about as well multimeter, and this simple trick how you can use an analog meter to see oscillations. It's really fun thing to do. You can change all sorts of waveforms, and if its frequency is really low, you can actually visualize it. And this is in this digital multimeter you won't be able to do it. It can show you the numbers between 0 to 18, but it can't show you this particular movement. This is very useful if you want to analyze things, and that's why I consider using an analog multimeter along with a digital one when you're working with oscillators and analog circuitry, because it comes in really very handy. Thank you.